In this video, we'll be looking at Chapter 10, Section I.1 on trigonometric identities. Now, we've already seen a few trigonometric identities in our previous work. Recall that we discovered that the sine of 180 degrees minus theta is equal to the sine of theta. Also remember, one of the most basic trig identities is that tangent theta equals sine theta divided by cosine theta. And we've seen another trig identity, one of the most important ones, which I'll prove in just a second, once before. But this one you should definitely commit to memory, and that is cosine squared theta plus sine squared theta equals 1. I'm going to quickly go over the proof of this particular identity. So let's start with a picture of the unit circle again. Now remember from a previous video from section D that if we have a point P on the unit circle and it has coordinates x and y, well, those coordinates are actually equal to the cosine theta and sine theta. So we've shown that cosine theta is really equal to x, or the x coordinate, and sine theta is the y coordinate of point P on the unit circle for any angle theta. So that's where we're going to start our proof. Cosine theta equals x and sine theta equals y. But look at this triangle again that's formed with point P and angle theta. And notice that using Pythagorean theorem, we have x, which is this side of the triangle, and y. If we use those in Pythagorean theorem, we get x squared plus y squared equals the hypotenuse, which is 1. It's the radius of the circle, which is 1. So x squared plus y squared equals 1 squared, which simply equals 1. Well, I have an expression for x, which I can plug in here, and I have an expression for y, which I can plug in here. If I do that, I get cosine squared theta plus sine squared theta equals 1. Now it's very important to note how we write cosine squared theta. Cosine squared theta does not equal cosine of theta squared. These are two different expressions. And so it's important to look where the exponent belongs. Does it belong with theta or does it belong with cosine? In this case, I want to calculate what cosine of theta is first, and then square it. These two expressions are equal. And so it's important to remember that when we're dealing with this trigonometric identity. Let's take a look at that unit circle again. And remember we said that cosine theta equals x and sine theta equals y. Well, for cosine of 0, we have, cosine of 0 degrees, we have an x coordinate of 0 and a y coordinate of 1. For a theta of 0 degrees, we have a cosine theta equals 0 and a sine theta equals 1. And for theta equals 180 degrees, we have cosine is negative 1 and sine is 0. And I'm going to fix a mistake here. Okay, let's take a look at that again. So for an angle, a theta of 0, we have x coordinate of 1 and a y coordinate of 0. Those relate to cosine and sine. And for an angle of 180 degrees, I have an x coordinate of negative 1 and a y coordinate of 0. Notice that this is the rightmost that I can get on the unit circle, and this is the leftmost that I can get on the unit circle, which means that my x-coordinates cannot be greater than 1 or less than negative 1. So we're going to go back to our inequalities here, or set notation, x has to be between -1 and 1, which means that cosine of theta has to be between or equal to -1 and 1. Likewise, I can show that sine of theta has to be between -1 and 1. And this is true for all angles theta because of the unit circle. So when you get an error in your calculator, because you're trying to take the inverse cosine of 2, that's why. So let's take a look at an example problem. In this problem, we're asked to find the exact value of cosine theta, not theta, but cosine theta, if sine theta equals 1/3. Now we're given two conditions. The first condition is that theta has to be between 0 and 90 degrees. And the second condition is that theta has to be between 90 and 180 degrees. So let's use one of our most famous trig identities, and that is cosine squared theta plus sine squared theta equals 1. Well, I know what sine theta is. Sine theta equals 1/3. So I can plug that into my equation here. I have cosine squared theta plus 1/3 squared equals 1. Because sine theta is 1/3, so I need to square the 1/3. Well, we can do a little simplification here. Cosine squared theta plus 1/9 equals 1, or cosine squared theta equals 8/9. But remember that the question is asking for us to find cosine theta, not cosine squared theta. So I need to take the square root of both sides. And when I do that, I get two answers or two values for cosine theta. I get plus or minus the square root of 8/9, which is really equal to plus or minus 2 root 2 over 3. And that's going back to simplifying rational expressions. I encourage you to review that if you're wondering what this step was right here. Now for part A, I was asked to find theta between 0 and 90 degrees. And for this, I need to sketch my unit circle here. I know that theta between 0 and 90 degrees is this quadrant right here, the first quadrant. I also know that for all points in this quadrant, the x-coordinate has to be a positive number because I'm on this side of the x-axis. X has to be a positive number. So cosine has to be a positive number because remember, cosine of theta is equal to x for this quadrant. So for part A, the solution that I'm going to use is positive 2 square root 2 over 3 because cosine has to be positive between 0 and 90. Likewise, between 90 and 180 degrees, cosine has to be negative. X is negative here, and y is still positive. But cosine is negative between 90 and 180, so I'm going to use the negative form of my answer for part B. So when doing these questions, always look at the condition that's being given. Is theta between 0 and 90? Is it between 90 and 180? Is it between 0 and 180? Or is it between some other range of angles?